Hi students, today we are going to learn about areas of similar triangles. Theorem 6.6. The ratio of the areas of two similar triangles. If the triangles are similar, then the ratios of their area is equal to square of the ratio of the corresponding sides. That means if the given considering a triangle ABC and PQR, if these two triangles are similar, considering these two triangles are similar, then the area of the triangle ABC and PQR, the ratio will be the area of ABC and the area of PQR. Their ratio will be equal to square of their ratio of the corresponding side. The corresponding sides ratios squares is the area of their square, area of their similar triangles. So the similar triangles are ABC and PQR. If they are similar, then the corresponding sides AB by BQ the whole square or is equal to BC by QR the whole square, or if it is AC by PR the whole square. If any corresponding sides is given, then we can find the area of the both the triangles in the ratio. Clear, children? So here we go for the problem. Exercise 6.4. Let the triangle ABC is similar to triangle DEF and their area be respectively 64 centimeter square and 121 centimeter square. If EF is equal to 15.4 centimeter, find BC. So they given it is the similar and we have to find the area. So it is given similar. If it is not given the similar, we have to prove it is a similar. So it's already given it is a similar. So given triangle ABC is similar to triangle DEF. So area of ABC by area of DEF is equal to, we will be getting a 3 corresponding sides ratio, right? But it is enough that which data we have, that is enough. So it is given a EF. EF is the last 2, right? Then it is a BC. So BC by EF the whole square. Even we can say that it is also equal to first to AB by DE the whole square, and also we can say first and last AC by DF the whole square. But these two data we no need, because since it is given EF and BC, so this is enough. This two is no need. So which side is given, which we needed, that alone we can take. So area of ABC is given as 64. Respectively given the first triangle is in ABC, it is a 64 divided by, and the DEF is in a 121 is equal to BC is what we have to find, divided by EF is 15.4 the whole square. So let me take a square root on both sides. So it will become a square root of 64 divided by 121 is equal to square root of BC by 15.4 the whole square. And square and square root will be cancelled. And square root of 64 is 8. And square root of 121 is 11. 8 8 is 64. 11 answer 121 is equal to BC by 15.4. So while taking this side, it will become a multiplication, right? So 8 by 11 into 15.4 is equal to BC. We can cancel it. 11 it is for 14 times, that means 1.4. So 1.4 into 8 is 14 into 8 is 112. 1.4 into 8 is 11.2, right? So therefore BC is equal to 11.2 centimeter. Here we go for the next question. Diagonals of a trapezium ABCD with AB parallel to DC intersect each other at O. So it is given a diagonal for a trapezium ABCD. Let me draw the trapezium ABCD, and AB is parallel to CD. So I am drawing a parallel side and I am connecting the not parallel side and naming it as an ABCD. Diagonals of trapezium, it's connecting and intersecting at point O. So we are connecting that diagonals, and that intersecting point is O. If AB is 2 times the CD, and find the ratio of area of the triangle AOB and COD. then AOB and COD. So they are saying to find the area of this. Then first we have to prove this both the triangles are similar. Then one of the side is given AB by CD. So AB and CD is given. So easily we can solve, right? So we know this. This is also easy, right? This angle and this angle equal since the vertically opposite angles. And this are equal since alternate angles are equal in the. Since it is a parallel line, so opposite alternate angles are equal, right? So the given is a trapezium ABCD with AB parallel to DC, and also this given AB is equal to 2CD. So first we have to prove these two triangles are similar. So in triangle, which two triangle we are choosing? AOB and triangle DOC. So here we know this AOB and DOC are equal. Angle AOB is equal to angle DOC since it's a vertically opposite angle, right? And next, these two are equal, we can say by the alternate angles are equal. So angle OAB is equal to angle OCD. Alternate angles are equal. This we can say only if both are parallel. So the parallel side we have to know distance given. So by which criterion it is equal? By AA Larity criterion. So triangle AOB is similar to triangle, the O is corresponding to O, A is corresponding to C. So A is corresponding to C, O is corresponding to O, and B will be corresponding to the rest is the D, COD. So therefore this area will be, so area of AOB divided by area of COD, the ratios will be in the corresponding sides. So we know that given is the AB and CD. So let we take the side which contains AB and CD. So AB by CD the whole square we can take, right? AB by CD the whole square. AB by CD. The rest two is also there that we no need since we don't have that data. So we can write AB is equal to 2CD and it will be get cancelled and we will be getting in the ratio, right? So AB we can replace by 2CD by CD the whole square. CD cancel, that is 2 by 1 the whole square, right? So 2 by 1 the whole square is means 4 by 1, right? So area of AOB by area of COD is equal to 4 by 1. So the required ratio is 4:1. The ratio of the area of triangles AOB and COD is 4:1. So here we go for the next problem. In figure, A, B, C and D, B, C are two triangles on the same base BC. If AD intersect BC at O, show that the area of ABC by area of DBC is equal to AO by OB. So it is given the same base of the two triangles. So we can prove this theorem by the area of the triangle by the normal formulas, half into base into height. So let me construct a height which is perpendicular to here, this triangle here. So we are going to construct here, since we are going to prove by the normal area formula 90 degree. So let it be L and M. Since here the proof area is telling about AO and DO, which is a line in between that, it is not a side. So AO and DO is not a side, right? So that's why. So what we constructed, So construction is draw AL perpendicular to BC and DM is same perpendicular to BC. So BC is the same base that we have taken. So now let me prove these two small triangles are similar, so that we can say that AO and OC will be the same proportions, right? So in triangle ALO and the triangle DMO. So here we know these two angles are vertical opposite angle, and these two angles are 90 degrees. By double A we can say directly. So angle ALO is equal to angle DMO, which is equal to 90, right angle. And the next is vertically opposite angle AOL. Angle AOL is equal to angle DOM, since it is a vertically opposite angle, right? So by double A similarity criterion, triangle ALO is similar to triangle. So L is corresponding to M and O is corresponding to O, and then the rest is the D. Then A will be corresponding to D. For L it is a M, and for O it is a O. So therefore, if we have proved the similar, then the ratios will be the same, right? So AL by DM, AO by DO, which is equal to LO by MO, right? So now, so what we require, it's a area of a triangle ABC and DBC. So area of triangle ABC by area of triangle DBC is equal to the normal half into base into height. So half into, in triangle ABC, what is the base? Base we will take common BC and height is a AL. Half into base BC into height AL divided by the same here. In this triangle the base is BC, the height is DM. So half into base BC into DM. So the half of get cancelled, BC get cancelled, we obtained AL by DM, right? But we have to prove it as an AO by DO, right? So here we said that AL by DM is equal to AO by DO, so which is equal to AO by DO. That's our proof. So here we go for the next problem. If the areas of two similar triangles are equal, prove that they are congruent. So already we know that all the congruent triangles are similar, but here it's including the areas. If the area of the two triangles are equal, then it is a congruent. We are going to prove it. I think really this problem is interesting, because this result we can remember easily, like how we remember all the congruent figures are similar. The same way we can say if the area of the similar triangles are equal, then they are congruent. So let me consider triangle ABC and PQR. So this we consider, right? Since it's not there, let me write. So let triangle ABC is similar to triangle PQR. It doesn't given any name for the triangle, just I consider this as, and the given, what is given, then the area of that similar will be equal. So area of ABC will be equal to area of PQR, right? So then we can bring this division, so that we will be writing as a normal formula, area of triangle ABC by area of triangle PQR is equal to 1, right? So now normally we know that the area of triangle ABC by area of triangle PQR, by the formula we know that AB by PQ the whole square is equal to PC by QR the whole square is equal to AC by PR the whole square, right? Here we know that it is equal to 1. So we can say it is also is equal to 1. Right? So normally the for each and every terms is also equal to 1. So AB by PQ the whole square is equal to 1. If you take square root to that side, square root of 1 is a 1. So AB by PQ is equal to 1. So AB is equal to PQ. So we already know, since it's a similar, all the angles are equal. Here we know it. Here we have to prove all the sides are equal. Then all the corresponding sides are equal. Then it is the congruent, right? So here is also same. BC by QR the whole square is equal to 1. By taking a square root, we can say BC by QR is equal to 1 and BC is equal to QR. And third side, AC by PR the whole square is equal to 1. So AC by PR is equal to, since taking the square root, so AC is equal to PR. So this is what we have proved, and already we know that angles are equal, right? Angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R. Since it is given the similar means all the angles will be equal. Therefore, triangle ABC is congruent to triangle PQR. This is the congruent symbol. So here we go for the next problem. DEF are respectively the midpoints of the side AB, BC and CE of the triangle ABC. So there is the triangle ABC and the D is on the side AB and E is on the side BC and it is on F on AC, right? Find the ratio of the area of the triangle DEF. So let me connect DEF. So this small triangle and the big triangle, we have to find the areas ratio. So we know that the two midpoints connecting lines will be parallel to the third line, right? Since we have learned in the 9th standard midpoint theorem, right? So therefore, for let me take this triangle for D and E. Let I'm talking about this. So D and E are midpoints of triangle ABC. So therefore, DE is parallel to AC, and we can say DE is equal to half of AC. By what? By midpoint theorem. We have learnt already, right? If that line containing the two midpoints will be parallel to the third side. So let me choose the two triangles. This small triangle, this because we have the data of this, and the big triangle, and let me check whether it is similar or not. So in triangle BED and triangle ABC, sure the B is a common, right? This B angle is the common for this triangle and this big triangle. So angle B is equal to angle B, since it is a common. And the next one, we can say that these are the parallel. We already said, no, D is parallel to AC. Then this angle and this angle will be equal, since it's a corresponding angles in the parallel line. This is the parallel line and this is the transversal which cuts. Then these are the corresponding angles. So angle BED is equal to angle ECF, the corresponding angles. So equal, right? So by AA similarity criterion, I can say that triangle BED is similar to triangle B is corresponding to B, and E is corresponding to C, and the rest is A. So these two are similar. So if you after finding the similar, we can go for an area. So area of BED by area of BCA is equal to, we will be having the ratios but we can choose the ratios which admits the side AC and DE. AC and DE. This is a DE and AC, right? So ED by, it's because that we have values, whole square. So ED can be written as half of AC, right? Or the AC can be written as 2 times ED. So ED by 2 ED the whole square, and ED get cancelled. It is a 1 by 2 the whole square, which is equal to 1 by 4. Now it is in the ratio 1 by 1/4, right? Similarly, we can prove for this triangle EFC and ADC, this small triangle and this small triangle also we can prove. We will be getting as a 1 by 4, right? So similarly we can write, we no need to prove that much. So area of triangle CFE by area of triangle BCA is equal to 1 by 4, right? Same, the area of triangle ADF by area of triangle BCA is equal to 1 by 4. So now we are going to compare the area of DEF and this full triangle, right? We know that, so DEF triangle is we can obtain by the big triangle minus this small 3 triangles, right? So we know this small 3 triangles as a 1 by 4. This we can write as an area of CFE is equal to 1 by 4 of area of BCA, right? The same, this also we can write area of CFE is equal to 1 by 4 of area of BCA. So everything is 1 by 4 of the big triangle. The small triangles is the 1 by 4 of the big triangle. So big triangle minus the small 3 triangle, we will be getting the inside central triangle DEF, right? So area of DEF is equal to area of the big triangle ABC minus that the 3 small triangle, area of BED plus area of EFC plus area of ADF, right? So this is equal to area of ABC, and this everything is a 1 by 4 of the ABC, right? So 1 by 4 of ABC or BCA, whatever the order is, doesn't matter. ABC plus 1 by 4 of ABC, so area of ABC, right? Plus 1 by 4 of area of ABC. So it will become a 3 by 4 of ABC, right? Here it is the area of triangle ABC minus 3 by 4 of area of triangle ABC. So 1 minus 3 by 4 means cross multiply 4 minus 3 is 1. So balance is a 1 by 4. So 1 by 4 of area of ABC. So here is also the same 1 by 4 of ABC. So here is the area of DEF. We need a ratio in terms of DEF and ABC, right? Let me bring this side. So area of DEF divided by area of ABC is equal to 1 by 4. So the ratio is 1:4, right? DEF and ABC, that's what I written, DEF and ABC. So instead of BCA, I have written here ABC, since the order doesn't matter in finding area. Finding area of ABC or area of BCA, it represents the same triangles, and here I am not representing a similarity to prove the corresponding angles, so order doesn't matter. We can write according to our convenience. Thank you.